Hi, it's Karen Gregorian. In the last video, I showed you examples of visible connections between web pages. In this video, I'll show you how to actually create those visible connections. I'll start with a few examples. I'll explain the theory behind them later. First, I'll show the simplest scenario, and then we'll move on to more complex ones. The first scenario is creating a post on a WordPress site. Don't worry, you don't need to have a WordPress website to publish visible connections. It's just the simplest example to start with. Other scenarios will follow. So, let's assume you have a WordPress site with the static web publisher plugin installed. First, you create a post as usual. I'll add some text here and save it as a draft. The post isn't published yet. Now I go to preview. From the layout, you can see that the page is presented as an HDoc, or hypertext document. Next, I want to add another page on the right side. Let's say I want to connect this new post to some other page on my site. All I need to do is copy the URL of that page, return to the preview, open the extensions pop-up, and paste the URL here. When I click load, the page appears on the right side of the screen. Now I can create floating links. To create a floating link, I select a range of text and press L on my keyboard. Then I select a range of text in the other document and press L again. The floating link is created. Let me create another floating link. Once all the links are created, it's time to save them. I press this button and copy the source code. Now I go back to the editing page. I find the field called Connections Info. You may need to make sure the Settings tab is selected, and within it, the Post tab. I paste the source code into that field and save the draft. When I return to the preview page and refresh it, you can see that the page now knows which page it's connected to. The links are visible, and I can even download the connected page and see those connections there as well. All of this works before the post is published. To publish it, I would just go back to the editor and press Publish. I won't do that for this post, though. By the way, if you've created a floating link and want to delete it, just select it in the middle and press Backspace. And if you're in the middle of creating a new floating link but change your mind, simply press Escape and the selection will be cleared. I can create a new link here, then export all the floating links again, and update the connections info on the editing page. Now let's look at another scenario. Publishing a standalone HDoc file. Currently, I'm in the file manager looking at the files I have on my server. Let's say this is a file I want to publish on my website. I'll explain the format later after we go through a couple of examples. Normally, when you publish a standalone file, you upload it and then add a link to it from some existing page. Before that link is added, nobody knows the file exists, so it's perfectly fine to upload an unfinished document. In this case, I have uploaded an HDoc without any connections. I'll add them later. Once the file is uploaded, I open it in the browser. From here, I repeat the same steps as before. I find a page I want to connect to, copy its URL, paste it into the pop-up, and load the page on the right side. Then I create floating links. After that, I export the connection source code. This time, instead of pasting it into WordPress, I paste it directly into the file, right after the content section. I refresh the page in the browser and that's it. I've published a page with visible connections. Oh, wait, I need to purge the cache to see the result. Let me update the page again. Now we can see the connections. In the very first example, I showed you how to create a page that works both as a regular HTML page and as an HDoc if the user has HDoc compatible software installed. I demonstrated this using a WordPress site and a special plugin, but you can achieve the same result by manually creating a file and uploading it to your server. But first, let's look at the source code of the page in the first example. Down at the bottom, there's a block of data that contains some metadata, panels, and visible connections. The panels block contains some links. Here are those links on the page. Where do they come from? They are configured in the settings of the Static Web Publisher plugin. Another thing worth noting in the source code of the page is that the main content of the page is marked with a special class called HDoc content. It was marked by the plugin, but as I said before, you can create such page manually. You don't need a WordPress site and a plugin for that. Let me give you an example. Here I created a regular HTML page and uploaded it to my server. Here is its source code. The element that has the text of the post is called article. Let me add a special class name to it. Then let me add a block of JSON data. It should have an ID of HDoc data. I will only add a title to it. Now I just save the source code and refresh the page. Now you can see the page rendered as an HDoc. And if I close the reader, you'll see the original page again. That's exactly what most people will see if they don't have the special software installed. Now let's talk about document types. There are two main ones, HDoc, hypertext document, and CDOC, collage document. If you look at the source code of any page, you'll see that it's either an HDoc or a CDOC. There's also a CONDOC, or connections document. A CONDOC simply imports another document as its main document. If you open the source code of a CONDOC and look at the main document tab, you'll see that the main document is again either an HDoc or a CDoc. Let's take a closer look at these formats. An HDoc can contain metadata and panel information. Panels can be placed at the top and the bottom. There can be a side panel for comments or an iframe. In this example, we only have a top panel with a set of links. There can also be a header with the title and other visible metadata, such as the publication date and the author's name. The content itself is just a tag containing HTML or plain text. In this case, the content is plain text, which is indicated by the type attribute of the content tag. Right after the content, a page can define connections to other pages. For each connection, it specifies a URL, a title, the hash of the target document, and a list of visible connections, also called floating links. A CDOC can also have metadata. Its main content is an SVG image, and just like an HDoc, it can include connections to other documents. I've already shown you how to publish HDocs, but what about CDOCs? Since the content of a CDoc is just an SVG file, you can use any tool you like to create it. Personally, I use my app, LZ Desktop. You can find it on the Downloads page of my site. It is available on Windows and Mac OS. I also recommend using the companion browser extension called LZ Desktop Helper. First, publish the images you want to use on your website. For this example, I'll use a couple of random images from my site. I can right-click each image and send it to my app. Inside the app, I use a collage frame to create a collage. Once that's done, I open the collage as a document and export its source code. I then copy that code, create a CDOC file on my server, and paste the source code into it. Now I can see the same collage in the browser. While I'm here, I can create visible connections just like I showed you earlier. I use the L button to create them. They don't make much sense. I just want to show you the mechanics of creating floating links. After floating links are created, I export the connections and paste them into the CDOC file on my server. I purge the cache, refresh the page, and now the collage displays the connections built directly into the document. What's especially interesting about HDocs and CDocs, particularly HDocs, is that they are virtual documents. They are constructed locally in your browser. If you look at their source code and compare it to the source code served by the server, you'll see differences. Let me give you an example. This document looks broken to someone who doesn't have the special software needed to view it properly. For those users, I've left a message on the page instructing them to install the Visible Connections Chrome extension and refresh the page. If you look at the real source code, you'll find that message inside fallback tags. But once the page is refreshed and rendered as an HDoc, the message disappears. Moreover, if you inspect the source code of the virtual document, the message is gone there as well. Here's another example. This is a normal HTML page with an embedded HDoc. I have already shown you how to create such a page. This format is different from a standalone HDoc, but the client app can still use this information to construct an HDoc locally. If you look at the generated source code, you'll see that it looks just like a normal standalone HDoc, with a note indicating that it was generated locally using embedded HDoc data. So there are two different kinds of documents you can host on your website that end up being converted into the same format. Actually, let me show you the full picture. Imagine a screen where two documents are shown side by side. The document on the left is hosted on your website. It can be one of three formats: a standalone HDoc, an embedded HDoc, or a standalone CDoc. CDocs are always standalone. This main document can connect to a wider range of documents. On the right side, the connected document can also be constructed from those same three formats, but in addition, it can come from regular HTML pages or plain text documents. You can create HDocs from both of those, but you need to specify parsing rules. Parsing rules are added to the document's URL. Here's an example of what they might look like. I'll explain how to create them in a moment. A CONDOC, or connections document, imports not only the documents on the right side, but also the main document shown on the left. This means that it can import the same wider range of document types on the left side as well as on the right side. In this example, the URL of the main page inside a CONDOC has parsing rules. The page itself comes from Wikipedia, and it wouldn't have worked without parsing rules. Let me show you what happens if you try to connect to a random page without parsing rules. Let's say I want to connect a page on my site to this page from Wikipedia. I copy the URL and paste it in the extensions pop-up. I get some error. In the previous examples, I simply used the document's URL when creating a connection. That only worked because the target document was already in a format that supported HDocs. In other words, the document itself contained all the information needed to construct an HDoc locally. When connecting to regular HTML pages, you have to use parsing rules. Let me copy the URL with parsing rules this time. Now the page is loaded successfully. Now let's look at how to create parsing rules. First, let's get the simplest case out of the way: plain text documents. If you want to connect to a page that is just a text file, like the book shown here, you simply add #PR equals text to its URL. More commonly, though, you'll want to connect to a regular HTML page. Parsing rules for HTML pages are a bit more involved. If you inspect the source code of a web page, you'll see that it consists of a hierarchy of tags. Typically, we need to identify the tag that contains the main article text, without navigation elements, comments, or other clutter. We also need to identify the title and, optionally, the author and publication date. Often, we also need to remove certain elements from the resulting document. To do all this, we use selectors. Parsing rules are made up of pairs of strings, a letter that identifies the type of selector followed by the selector itself. Here is a list of all currently supported selectors. The Visible Connections extension includes a built-in tool to help you create parsing rules. When you're on a page you want to connect to, open the extensions pop-up and click Open Parsing Rules Editor. A selector is a piece of text, usually used by programmers to identify elements on a page. Selectors can be quite complex, but in practice you usually only need simple ones. I've created a page with examples of common selectors. Use this link to open that page. Let's look at the basic syntax. Suppose you discover that all the content on a page is inside a tag named article. In that case, you can use the tag name itself as the selector, and the parsing rule would look like this. Often, the content is inside a div with a specific class name, such as entry content. In that case, the selector would be div.entryContent. In many cases, it's safe to omit the tag name altogether. Then the selector becomes simply .entryContent. Titles can be identified using selectors as well. Here's an example of parsing rules that include both a content selector and a title selector. On most pages, the title is inside an H1 tag. When that's the case, you don't need to specify a title selector at all. H1 is used as the default title selector anyway. You can create parsing rules manually if you want, but let's see how the Parsing Rules Editor can help. In the Parsing Rules Editor, the right-hand side contains fields for selectors. On the left, you see the parsed page. At the top, there's a URL that includes the parsing rules. You use the fields on the right to choose selectors, and you use the page on the left to verify that the resulting document looks the way you expect. Once you're satisfied, you can copy the URL with the parsing rules and use it on any page of your website. The Parsing Rules Editor has built-in lists of the most common selectors for content and titles. Here's what those lists look like in the extension's source code. When you open the editor, the first thing it does is iterate through those selectors and try to find matching elements on the page. This results in much shorter lists containing only selectors that actually match something on the page. You can then use the buttons to cycle through all the found elements. Notice how the page on the left changes as you switch selectors. In this case, the first guess was correct. In many cases, the suggested parsing rules will be correct right away. Sometimes you'll need to look through alternative suggestions by cycling through the selectors, and in some cases there will be no good suggestions at all, and you'll have to add the correct selectors manually. Let's look at an example. I'm on a history website and the Parsing Rules Editor is already open. The first suggested content selector is correct, but the title is wrong. I open the same page in another tab so we can compare. It turns out that the selected title is the site name, not the page title. I cycle through the other title selector suggestions and one of them looks right. Once I'm happy with the resulting parsing rules, I can save them. Often, a website uses the same template for all its pages. Because of that, you can identify the correct parsing rules on one page and then reuse them for any other page on the same site. To demonstrate this, let me open another article from that site. When I open the editor on the new page, you can see that the saved parsing rules are applied immediately, and the preview on the left looks correct. At this point, I can simply copy the URL and use it on my site. If it's still not clear how selectors work, Let me open the source code and locate the title and content using the class names from the selectors we just identified. First, I search for an element with the class name entry title. Here it is. Next, I look for the content using the class name entry content. Here it is as well. Here's another example. The first suggested content selector is correct, but no title appears at all. I cycle through the title selector suggestions, but none of them work. I open the page in a separate tab and inspect it with DevTools. The title is inside an H1 tag, which seems correct. I then open the source code and search for H1. Now the problem becomes obvious. For some reason, there are two H1 tags on this page. We need the second one, but the first one is selected automatically. The H1 tag we need doesn't have a class name or an ID, so how can we identify it with a selector? In this case, we can use a scoped selector. The H1 we want is inside an article tag, while the H1 we don't want is outside of it. So we can simply use article H1, which literally means find an H1 tag that is inside an article tag. Once I press Apply Changes, you can see that the title appears in the preview. Now, let's see if we can identify elements that contain the publication date and the author's name. Once again, I open the page in another tab and inspect it using Developer Tools. With the element picker, I can see that the publication date is inside a span tag with the class date. The author's name, however, is just a plain text string that comes after the date span. That means we can't identify it with a selector. That's fine. Let's at least use the date. I go back to the editor, type .date into the publication date selector, and apply the changes. You can see that the date now appears on the preview page right after the title. Let me also show you how to remove unwanted elements from a page. If I scroll down, I can see some social media buttons that aren't really part of the article content. Let's remove them. I open the Developer Tools. On my machine, that's Option, Command, and I. If that doesn't work for you, just search for how to open DevTools on your system. Using the element picker, I select one of the social buttons and then find the root element that contains all of them. Here it is, a div with the ID social ads. Back in the editor, in the Removal Selectors field, I type #social ads and apply the changes. The social buttons are now gone. At this point, I can save the parsing rules for this website. By the way, if you press this button, you'll see a list of all saved parsing rules for all websites. At first, this list will be empty. There's also a link to a page on my site where I plan to collect parsing rules for popular websites. You can contribute to that list through the comments section. For now, the simplest use of this list for you is to copy it and paste it into your parsing rules editor. Now let's talk a bit about the title and why it's pink. In an HDoc, the title should live inside the header element. Other elements, such as the publication date and the author, can also go inside the header. All of these elements are thus separated from the main content. In practice, though, the content tag most of the time contains raw HTML, and there's nothing stopping you from placing an H1 tag inside the content itself, right before the rest of the article. The problem with doing that is future changes. You may later want to update the title, add an author, or add a publication date. If the title lives inside the content and you change it, you can break existing floating links on the page. It's not a disaster. Those links have self-healing behavior, and it's even less of an issue when you're linking to pages on other websites. But there is still a preferred way to structure things. Regardless of whether the title is placed inside the header or inside the content, it looks the same when the page is rendered. To make this distinction visible in the editor, I chose to render the correctly identified title in pink. You actually want to see a pink title. If it isn't pink, that's a sign that something may be wrong, and it's worth investigating how the title is being detected. There is also a built-in tool for creating CONDOCs, or connection documents. After you configure the parsing rules, you can press this button to open the CONDOC editor. You'll see that the URL of the main document is already included, and you can edit the title and description. It's better to do this here than to create a CONDOC manually because some characters need to be escaped, and the tool handles that automatically. For example, notice how the ampersand is escaped when I add it to the title. Once the title and description are ready, you can copy the source code and save it as a standalone file on your server. By the way, before uploading any files to your server, you should read my note about publishing standalone files. To find it, open the extensions pop-up and follow this link. Here it is. The core idea is simple. Browsers tend to download files with unknown formats, but we want documents like HDocs, CDOCs, and CONDOCs to remain in the browser so the Visible Connections extension can work with them. To achieve that, you need to configure your server in a specific way. In the note, I explain how to do this on an Apache server and on a WordPress website. If your backend is different, you'll need to figure out how to handle it in your case. You can always consult ChatGPT for help. Finally, let me show you a few tricks that you might find useful. I've already shown how you can add a fallback message that is visible only to people who don't have the Visible Connections extension installed. For that, we used a special tag called fallback. That approach doesn't work for embedded HDocs, however. In those cases, there's a special class you can apply to any element to completely remove it from the final HDoc. Let me show you how this works. Here, I add a block of HTML, a paragraph with red text, and give it the class name HDocRemove. Now I save the document and refresh the page. As expected, the message is not visible. But if I close the reader, you can see it. Now, what if you want to do the opposite? What if you want an element to be visible only in an HDoc and not on a regular page? In that case, you simply add the element and set its display style to none. On a regular page, the style will be applied and the element will be hidden. In an HDoc, however, it will be visible because HDocs don't respect styles. Let me add a paragraph here. Let me add a style to it with display set to none. Now we can clearly see that paragraph in the HDoc. But if I close the reader, we see that on a regular HTML page, that paragraph is not visible. You might also be wondering why the floating links are still in the correct positions, even though I just changed the page content. Notice that the export button is now visible, and if you open the list of floating links, you'll see the message, "Floating links were modified." This means the floating links were technically broken, but the program fixed them automatically. You can even see what they looked like before the fix. Let's fix them again. Now I can export the links with their updated positions and save them. This kind of automatic fix isn't always possible. If the text change occurs within the highlighted text or within the hash text range, which can sometimes be slightly different, the floating link will remain broken. Let me show you an example. First, note where the floating link starts in the text. Now I make a change in that part of the text. As you can see, that particular floating link is now broken. At this point, the only way to fix it is to delete the link and create a new one. After that, I can save the floating links again. And that's about all I wanted to teach you in this video. Now that you know how to create visible connections, go and build something interesting. And when you do, send me a link. On my website, there's a page called Community Resources. You can get to it by opening the extensions pop-up and following this link. Right now, it only contains materials I've created myself, but that's not how it's meant to be. I want it to grow into a large collection of examples of visible connections from many different websites. Help me popularize visible connections on the web, and who knows, maybe one day browsers will start supporting them natively. When that happens, visible connections could become a fundamental part of the World Wide Web, changing it forever.